Zebra Mussel Repellent by Mariam Sayeda and Fatima Sayeda.
Question. Can we use materials that are known to negatively affect or irritate zebra mussels to create a repellent for them without harming the rest of the environment?
Hypothesis. Combining zebra mussel irritants such as measured amounts of salt, vinegar, copper compounds, and potassium sulfate per gallon of water, we can create a repellent in paint or paste form or a mixture that will keep zebra mussels from sticking onto objects and organisms, so that it will decrease the harm to these objects, organisms, and the economy.
Objective. Our goal is to help stop the spread of zebra mussels because they cause great damage to the ecosystem and the economy. The purpose of this experiment is to help find a solution to a big problem in the USA, especially around the Great Lakes region. These mussels have spread to a lot of lakes now, hitching rides onto things like boats and other water vehicles. They are even in a lot of lakes in Minnesota, like Lake Minnetonka. We want to find a way to stop its harm because not only does it cost millions of dollars to the economy, it also causes harm to a lot of native species. They filter large amounts of plankton from the water and deprive the animals of it. This causes the fish and other aquatic animals to starve. They make colonies in pipes, which increases sedimentation and even stops water from moving in it. Not only that, when the tide goes down on some beaches, zebra mussels line the shore, causing serious cuts to unprotected feet or causing the closing down of beaches. A lot of scientists in many different fields are working on this problem, but they have not found a clear solution that is not harmful to the environment and is efficient. Our goal is to create a repellent out of substances known to cause irritation to zebra mussels that we can apply onto the objects that zebra mussels suction onto, so that they repel from them and not harm them.
Zebra mussels can be found in the Caspian Sea and other lakes in Russia. They stick to different hard objects and suck out nutrients out of the water. They are irritated by some materials such as copper. Many researches have been conducted to stop the spread of zebra mussels. The purpose of this experiment is to help find a solution to a big problem in the USA, specifically around the Great Lakes region. Zebra mussels are a type of mussels that originated from some lakes in Russia. Since then, these mussels have spread to many different countries, hitching rides onto things like boats and other water vehicles. They are especially abundant in the Great Lakes and some lakes in Minnesota, such as Lake Minnetonka. We want to find a way to stop its harm because not only does it take millions of dollars to the economy, but it also causes harm to a lot of native species. Zebra mussels stick to hard surfaces such as rocks and suck out algae and bacteria that native fish need to survive. They also stick to native mussels, preventing them from breathing, and eventually these mussels die. They stick to industrial pipes, clogging them by forming colonies inside the pipes. Removing them every year costs thousands and even millions of dollars to the government, affecting the economy greatly. In conclusion, zebra mussels are a big problem that need to be solved in the lakes of the US, and this is why we chose this topic.
There are a few things scientists are doing for this purpose, even though none have found a solution. One example is the experiment in Lake Minnesota using EarthTechQZ. EarthTechQZ is a copper-based substance that is registered for open water application. It has been used to control zebra mussels in Minnesota lakes. This experiment was conducted by MAISRC and USGS in Lake Minnetonka, and they hope to make this treatment available and efficient in other lakes as well. Another example is the experiment in Lake Minnetonka about anti-biofouling paint. Anti-biofouling paint is an experiment conducted by MAICRC. The paint is an enzyme-based material to prevent bifouling, which causes invasive species to spread to different lakes after attaching themselves to boats.
Materials. The materials we used in this experiment including disposable utensils for mixing, tanks, rocks, and mussels, repellent ingredients. We used 4 fish tanks, 4 rocks covered in zebra mussels, water from the same lake as the mussels, vinegar, potassium sulfate, copper sulfate, salt, plastic wrap, foil, gloves, goggles, disposable mixing, measuring, and grinding utensils. This picture is a picture of all the the materials that we used.
Experiment. In the first tank, we mixed 1 tablespoon of copper sulfate, 1 tablespoon of vinegar, 1 tablespoon of salt, and 1 tablespoon of banana as the potassium. We crushed the carbon sulfate and banana and we mixed them well with vinegar, salt, and into the water. The solution turned blue, but other than that, no reaction occurred as we mixed them.
In the second tank, we mixed 1 tablespoon of copper sulfate, 1 tablespoon of vinegar, 1 teaspoon of salt, and 2 tablespoons of banana as the potassium. We mixed them in the same way as before, and again, there was no reaction except for the water turning blue.
In the third tank, we mixed 1½ tablespoon of copper sulfate, 2 tablespoons of vinegar, 1 tablespoon of salt, and 1 tablespoon of banana as the potassium. The same thing happened and there was no real reaction.
The last tank was our control tank, and it contained a rock with about the same amount of zebra mussels, the same water, and the same temperature. Nothing was added to the water, and we used it to compare and observe the mussels.
Finishing up. We experimented in all the ingredients with varied amounts of each ingredient. In one of them, we had all the ingredients equal in size. In the others, in some there was more copper, in some there was more vinegar, in some there was more salt, in some there were more potassium. We decided to experiment like this to find which ingredient is most effective, so we can find the perfect amount of each ingredient to put into our repellent. These pictures are after we added all our ingredients to each tank.
Results. We checked the mussels after 3 hours. The solution had dissolved evenly to the water, but the zebra mussels were all still attached. After 6 hours, there are pieces of banana floating in the water, and the water had turned blue, but the zebra mussels were still attached. After 9 hours, the tanks were in the same condition, and all the zebra mussels remain attached to the rocks. After 24 hours since the experiment began, the mussels remained stuck to the rocks, and there was no reaction between them and the solution. In this graph, we can see that the number of zebra mussels remained constant throughout the experiment.
These pictures show the zebra mussel tanks at the end of the experiment.
Importance and real-life applications. These types of studies are important and useful because they can solve big problems and help the environment, the economy, and the society around us. These invasive species are very harmful and problematic to them. We need to find a way to stop its harm because not only does it cost millions of dollars to the economy, it also causes harm to a lot of native species and people in the region and out of it. Many scientists are trying to find solutions to these types of problems, but they are not found yet. This is why it is important to learn, research, and find out new things about this topic. Because of this, we carried out our experiment to search for helpful results. Although our results did not match with our hypothesis, we were not able to find a solution just yet. It was important because we were able to learn what we can to fix, change, and to make our solution work.
For future expansion, we can do many things, including finding better ingredients to make our hypothesis work, getting more resources and information, finding a way to test the ingredients before making the solution, and focusing on smaller parts as steps to our bigger goal to make it happen.
Credits to this presentation template was created by SlidesGo, including icons by Faticon, infographics, and images by FreePic. Thank you.